Okay. Okay, so here's 98. Don't worry. Yes, it is, Lanja. We'll get to that in a minute. I changed the due date. So if anybody was freaking out about that, I didn't mean it to be a stealthy due date thing. Looking at 98 right here. What's X bar? It's the sample mean, which is right there, right? 2 ounces. What's the population standard deviation? Population standard deviation is 0.1 ounce. And what's the sample standard deviation? That's what that one is, right? Sample standard deviation is, what would it be for this problem? Anybody? What's the sample standard deviation for number 98? Hannah's got it. 0.1, it says, is the population standard deviation. Now notice, a sample of 16 bags was taken. The weight of each bag was recorded. The mean weight was 2. Okay, that's the sample mean. And the standard deviation was that. Okay, that's the sample standard deviation. How do I know? Because it came from the sample. They're talking about the sample, right? The last sentence says population standard deviation. Now, is everybody okay with that? Definitely not. I'm sorry. Let me catch up again. Definitely yes. Read. I forgot which one's which. It definitely is. Let me stop saying definitely. If I know both the population standard deviation and the sample standard deviation, which one of those is better? Sample standard deviation's job is to estimate what the population standard deviation is. Do you understand what I'm saying? So if you didn't know how old a group of people were, couldn't you take a sample and then the mean you get would be your best guess at what the real mean is? Is that true? Yes. So if you took a sample and you took a standard deviation of that sample, that's your best guess for what the real population one is. Don't we know what the real population one is here? So they ask you what the sample standard deviation is, and then you forget about it, right? So I know that seems weird. It's like, why the problem tell me? Because any sample you take, you can calculate the mean and the standard deviation of the sample, right? So, but if I have the population standard deviation, I'm not going to use the sample one because that would just be an estimate if I don't know the population. And I do. I'm sorry. I'm being overly dramatic this morning. Might be because I have a dinosaur watching my every move. Is that all right? Is that better? Okay. So that's number 98. So a few problems I think give you both standard deviations. If you know the population one, I don't care what other one you know, you're going to use the population one. That's the real one. All right. Anybody else have questions? Did I miss anything? Questions from homework? Oh, and then I'll come back to this. Any questions from homework? I'll take a drink. Is that water? I don't know. Okay. So let me talk about something else. Let me see if I can do this. Do you guys now see Canvas? Okay, thanks, Malachi. Just wasn't doing right yesterday, so thankfully it seems to be okay. Right here, T-score practice. Some of you guys, am I doing all right? Is my internet, looks like it's freaking out. Can you guys still see me? Anybody? Is it? I'm good? Okay, I don't know. For some reason, I'm all like, all right. So T-score practice. It originally had a due date of like 2 days ago or something evil. So I'm sorry about that. I had put it for my other class, changed their due date, and then forgot to change you guys' due date. This is the one, let me see if I have it down here. Now you guys can't see that. Sorry. Hey, everybody. Okay. Share screen. Do it. Where is it? There it is. No, that's not it. That's the one. Bam. Now you can see it, right? This is the one that I put a video up on YouTube. Apology accepted. Okay. This is the one, I put the video of this up on YouTube. We talked about this last time. And I can't remember, we talked a little bit about these, but we didn't do these. I've got the video of this solutions up on YouTube. You go take a look. What's due for you guys on by Sunday morning? Just because I randomly put something in there. You need to do this side. So let's talk about this side. Right, these you can do if you want to. You can watch the solutions up on YouTube. We're going to do an example of T-scores here together in a minute. I'll take Toby away and get the whiteboard back. This side right here. Okay, so if you're not sure where this worksheet is, it's up on Canvas. It's called T-scores practice or something like that. This is the side I need you guys to do by Sunday. And the first thing I ask you is to randomly select 20 grades. Please, this is going to be so cool if you do this as I ask you to. Don't pick the first 20 grades you see, because then maybe 10 other people do the same thing and I don't have enough good data. I need everybody to kind of most likely pick your own sample from this. And how do you do that? You drop a pencil on there and you take that one, you close your eyes and you kind of pick one. Don't pick all the ones that have a 0.0 at the end, because then you have less to type. No, 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 no. Is that random? No. So try to truly be random. You can make little freaking designs in here and do stuff, right? Right, but it's probably best to like drop a pencil on it, throw a dart at it, close your eyes and point at it, something like that. Get 20 data points by doing that. Then you got to use one var stats to get your mean and standard deviation. And then I was incredibly nice and I gave you the formula to remind you guys you have to use the T-score because you're only going to know S. All right. So I want you to try that out. It's due Sunday. We're going to do an example, a smaller scale example of this together in a minute. All right. So any questions? Is there anything else due for points, homework or quizzes in this? Yeah, that's all I know about. Yeah. Could you post the T-score practice? Oh, as a PDF. Oh, I'm sorry. Yeah, I got to remember to do PDF more, and sometimes it just slips my mind because some of you guys might have trouble opening some of the Word docs. Oh man, my notebook. I'm keeping notes. Let's see. What was it? T-score practice as a PDF. Okay. Just in case you have trouble with the Word doc. So I'm sorry about that. I'm trying to remember to change it to PDF because PDF is more universally usable. Sounds good. Thank you. Anytime. I like it. Is 8.1 and 8.3 due for points too? That was the, all right, let me make sure I know what you're talking about. Hold on. Hey, everybody. Close that down. Let me share my screen again. Share. All right, so let's see. You mean, isn't this easy to go through? Here, the 8.1, 8.3 handout. I don't think I made that due. Yeah, we did that together. So I don't think I would make you turn it in also, right? This is this one. Let's see if I can open this up. You probably won't be able to see it. Can you guys see that? Did it follow me? Can you guys see the problem with the dolphins? Yes, okay, good. Does this look familiar? I mean, didn't we do this together? And then we did this side together? Yes? Okay, thank you, thank you. Please keep my sanity. Help me keep my sanity. Okay, so that we did together. If you missed one of those lectures, it's the video is up on YouTube. You can go watch us do this live, recorded live. All right, let me see, let me stop sharing. All right, anybody have any questions about anything we just went over? What do you have in addition to, so Lanja's question is good. You always have homework. You always have homework. In addition to homework, you have that Sunday assignment to do with that lot of data that we just went over. We have to randomly select 20, right? You got that to do. I like it. And then what's happening next, a week from today? Doodler. And then a week after that. I'm like, yes, okay. All right, you're welcome. You want grades. You want tons of grades. Okay, anything else before we get back? Let me see. Yeah, so the one a week from today is chapter 8. And then one a week from that is 9, maybe 10 also. I could actually omit 10 if I feel like it. So we'll see how I feel. Sounds good. Better. It has to. Sorry. I'm in a weird mood this morning. Anything else before we get back into, I want to do some T-score examples with you guys, and then we're going to start to step into chapter 9 a little bit. Anything else? Any other questions? No. Okay, so let me turn my dinosaur off. That's one of the strangest sentences I ever thought I would say. All right, bye, Toby. So I'm trying to stand. Let's see if this will work. I've put an ottoman on top of my table. I don't know. We'll see. See how I feel about this. I hate sitting around all the damn time. All right, so let me just play around with this until you go crazy. All right. Where did I put my, well, this is useful, Jeff. There they are. All right. So let's do a quick example from section 8.2. You're not going to be able to see my head, and I don't care. It's probably for the better. Right, this is where we introduce T-scores. So let's say, can anybody not see that well enough? Is everybody good with me? All right, I don't see anybody saying anything. It's good. Yay. So let's say I take a sample of, what do you got, Jeff? Of 41 things. 41 salamanders. Salamanders, yeah, they have tails, right? Do they have tails? Let's say I take a 41 salamanders and I get an average length of the salamanders to be 3.07 inches. Right. If there's any salamander fans out there, I'm sorry if this is not correct. I did not look this up. So this is on a special little island somewhere. And we also get a standard deviation from the sample of what you got, Jeff? 0.82 inches. All right, is everybody with me? Took a sample, I calculated those two things. Maybe I put my sample data into one var stats and did it, right? Am I allowed to use, let me say it like this. Am I allowed to do something to create a confidence interval? Let's say I want to create a 98% confidence interval. Am I allowed to do something, and why? What is it that tells me I can do something? What's the bare minimum requirement for us to meet before I can do something? Yeah, all right, I like it. Let's put those two things together. So is this a normal distribution? Yes, why? Yeah, n is greater than 30. Central limit theorem says it's normal enough when you plot the means. So it's like go to town. Let her rip, like Dr. Fauci would say. All right. So let's do a few things. And, well, very first thing is, so that's, can I do something? And now which score will I use? Do I use a T-score or a Z-score? What tells me that? Yes, good. I have to use a T-score because I don't know sigma. All right, and I got exact glare right there. Let me see. Is it coming from here? Or it's probably coming from my screen. Oh, well, too bad. Glare. It's glare. Oh, well, too bad. Is everybody with me? So I always get somebody who's like, when the hell do I use T and Z? Well, that's it. And the really beautiful thing is, you know, I let you use, make a formula sheet, right? Or I give you the formulas, right? So one formula was this guy, and one formula was this one. You probably can't see that worth anything. But this is x bar plus or minus z sigma. Okay, so when I know sigma, I use z if I'm allowed to do anything. When I only know s, I have to use t. The formulas tell you. So appreciate that. All right, so maybe. So what do I need to know to figure out what I almost just gave it away. What the t-score is. What two things do I need to know so I can use the chart appropriately? T-score chart, degrees of confidence, degrees of freedom, that's better. So Lewis, you kind of put the two things together. I need to know degrees of freedom and I need to know confidence level. Right, so I can figure out the t-scores. What's my degrees of freedom? 40, right? It's going to be n minus 1. And my level of confidence is 0.98. So actually what I really need is, let's do it. Let's go straight to what I need. What is alpha? What is alpha? Can you guys see that? That's better. There it is. Sorry, I wasn't even looking over there. Still finishing coffee. I understand that, Lewis. I got mine in my system earlier. I don't know if you could tell. All right. So alpha is 0.02. It's the area in the tails. If there's 98% inside, there must be 2% in the tails. So I love the wording on the chart. Let me see. How can I show this? Right? You got the two rows at the top. I pretty much always use this row for confidence intervals because confidence intervals always make two tails. So what area is in two tails? 2%. And I, at the moment, there it is. All right. So it's the second column in, right? 2% in two tails. And then I want to, so that column, and then I want to stop at 40. So if I go to that second column and I stop at 40, what t-score do you guys see? Why is it 40, not 41? Because what's the formula for degrees of freedom? The formula for degrees of freedom is n minus 1. And we went over that last time, I think it was. Oh, I didn't even look here. Let's see. Yeah, 2.423. Out. Now listen, this is going to become huge later today. Confidence intervals always makes how many tails? 2, right? Because then when I chop a confidence interval, it makes 2 tails. You guys with me? In chapter 9, I'm going to have something like I might test a claim that the mean is actually less than something. In that case, it would be 1 tail down. So that's why the chart separates it out. So alpha in general is the area in the tail or tails. And confidence intervals always makes 2 tails, right? All right, I like it. So weird. I can't, my head. Oh, there I am. All right. So we got T to be, what was it again? 2432? 2423. All right, let me stop for a minute. Everybody know where to find a t-score chart if you don't have one? Same place you find everything now, on Canvas. Canvas controls us all. Okay. So now I've got everything I need. Let me rewrite that formula. And then let me double check and make sure you can see it. Yeah, we're getting to the bottom there. I don't want to show you my pajama pants. Oh, well. I'll put a decent shirt on, but screw the pants. Let me see. All right. So now I got everything I need, right? I got the mean, 3.07. Give or take, 2.423. Standard deviation was 0.82. Divided by the square root of n, which is 41. So one of the big mistakes is people will put 40 there because that's the degrees of freedom, but you need n. N is 41. So what part of that will you do first? This part? So the better you are with section 8.1, the easier this section is, because the only difference in any of the work is you use a different chart to get the number that goes here. That's it. All right. So I'm going to make some room here so I can finish this up. Let me take you away. So we get 3.07, give or take. Who's got the error? Error. Sorry, hold on. I got to get my, come here. All right. What do I do? What is it now? 2.423. Let me see. Has anybody got it? 0.31. Let me see if I agree. Times 0.82 divided by the square root of 41.31. I like it. So we just did this part here. Let me make sure. Hey, look at it. Hey, there's work. So now I got 3.07, give or take 0.31. And now I just subtract it and you add it, right? So you'll get, oh man, my brain doesn't feel like doing this. 2.76. Yeah, up to 3.38. Thank you. All right. All right, let me stop there for a second. Are we done with the problem? You wish. You wish. Right? But let me make sure. Does anybody have any questions over anything we've done? And just to remind you guys, there's a lot more shit up here that's going to be on your paper, because I had to write the problem and do the work, right? So on your paper, you're going to just do the work. You're going to figure out what the X bar is, what the S is, what the N is, do the T stuff, get the degrees of freedom, get the T stuff, and then you just got to do this work, right? Just so you know, there's a lot more shit here because I had to write the problem there too. Okay, so any questions on what we just did? And then we can finish the problem up. Okay, every time I see Guy Fieri down there, I'm like, what the hell? Yes, 2423. 2423 Earth beam. Okay, so it was 0.02 area and 2 tails. So I'm in this column, and then I stopped at 40, right? Let me see if I can even do it. All right, there you go, Jeff. I don't know. Can you guys see that? There it is. Am I pointing at the right thing? I don't know. All right. So take a minute and try to write the conclusion to this. I'm going to make some room. I don't know if you guys remember what this represented. Right, lengths of salamanders. It seems that it says 2,000. Oh, I see. My little decimal point was too small. T-scores are basically Z-scores that have been allowed to grow a little bit. Right? So if we thought it was 2,000 something, that would be remarkably insane. That would be way crazy big. So we are, I forgot what it was already, 98% confident that the interval 2.76 inches to 3.38 inches contains the true population mean length of salamanders. Word salamander looks like somebody meant to write salad and just kind of put more letters in. I don't know. So the formatting of confidence interval conclusions, we are this confident that the interval we made contains the real whatever. Okay. All right. So any questions on all that? And again, the whole purpose is this is much more informative to me than just a single sample mean. If you give me an interval, I get a better feel for what the real mean could possibly be and how certain you were, all this kind of stuff. I mean, this is not bad, right? I mean, from what we found, is this evidence that the average length of salamanders on this island is less than 3.5 inches? Is this evidence that the average length of salamanders on this island is less than 3.5 inches? What do you think? Ruh-roh. Uh-oh. Those are all wrong statements, right? Isn't the whole interval below 3.5? Yes? So this is evidence. I didn't say strong evidence. I didn't say weak. I didn't clarify what kind of, but it is evidence that the salamanders on this island have an average length of less than 3.5 because the highest thing I got in my interval was 3.38. Is it proof that they're less than 3.5 inches on average? Hell no. You can't really prove a damn thing ever, kids. It's too bad. You can show evidence. That evidence could be strong or weak, but you can't prove something. Isn't there still a 2% chance? Yeah, of course. Yes. I love it. That's why it's evidence. Do you guys, most of you guys were probably, thankfully not born yet when the whole O.J. Simpson thing happened, but a lot of us learned about DNA evidence. If your DNA is a match for blood found at the crime scene, is that proof that you were there? No, it isn't. There is a, what is it? I think it used to be like 2%. Now there's a point something percent chance that your DNA just happens to match the DNA to a certain degree with the person who was actually there. But it's a very small chance, right? But that's why, so that's evidence. So yes, Malachi says there's still a 2% chance, which is why it's not proof. If there was a 0% chance to be outside of here, it's proof. There's a 2% chance it's outside of here, it's evidence. Within a reasonable doubt, does that sound familiar? Does 2% sound like a reasonable? Yes, that's reasonable, so that's evidence. Okay, I like it. Maybe. Okay, now I want to tell you, this is so weird. I could just do this. I want to tell you, we're going to get into chapter 9, which is a much better process for testing claims. Confidence intervals are a little sucky for testing claims, but they're very quick things to calculate that you can kind of get a feel for whether a claim looks right or not. But they're not the way we test claims officially. Okay, let's do one more example, actually, just to remind you about one var stats. I'm going to erase all this. No, you don't go there. Get over here. So let's say that I have a normal population, and I take a sample of 7 things. And here they are. Normal population, let's say, oh gosh, I don't know, Jeff. I don't feel, of what? I don't know. Of, I don't care, ages, what, sure. And let's say, here are the ages I get. Yeah. How many is that? 1, 2, 3, 4, 5, 6. Look at me. That's my sample. And I want to construct a 90% confidence interval for the true mean age. Let me stop for a minute. Do you guys see the only difference between this problem and the last problem we did was I gave you X bar and S. Did I give you X bar and S? No. Why? Because I'm evil. Can you guys take a minute and put that list into OneVarstats and figure those out for me, please? If you forgot how to do that, well, shit. Let's see. Turn on calculator. Error. Shut up. All right, let's see. Oh, crap. Somebody's not 1,700 years old, Jeff. All right. 15, 16, 17, 21. All right, so. So put that in your list, right? Put it in the list 1. Then you go to stat, calc, OneVarstats. Good old OneVarstats. I don't know. Can you guys see that? Yes. Good old OneVarstats. So L1, I got no frequency list. Can't get no. All right. So I get these things. There they are, Jeff. Right? Is that what you guys got? Anybody having trouble with that? I could have put my data in wrong. All right, so me and Laurel, we're wrong together. No, we're good. We're all right. So the sample mean is 25.43. Let's round it to a couple places. Let's be a little bit reasonable. What's the standard deviation? Yes, in this case, you're right. I like it. It's not, do you see how, no, come on. Remember what I said earlier? I always get somebody's like, but you said if I've got the population standard deviation, I ain't got it. I don't have it. Why does the calculator tell it to me just in case what I put in was a population? Was it a population I put in? No. I'm the human. That's the piece of, technology. I have to know what the hell I'm doing. So S is 16 point, what was it again? 410? Yes. So now we're back to where I started on the last problem. I've given you exactly the same amount of information here. Just finish that problem out, please. Create the 90% confidence interval. You got to know what alpha is, degrees of freedom. Why are we allowed to do this problem? N's not greater than 30. What the shit? Did I forget my meds this morning? Why are we allowed to do this problem? Yes, this is normal. I don't care how big the sample is. It's normal. All right. Do it. I'm going to go take a quick nap. Maybe I should work on it too. Yeah, it's overrated. Let's see. It is overrated. Let me make sure I'm not in the way of anybody. There it is. Oh yeah, got to figure out what T is. Wait, let me put this down here. Whoa. Go in the basement real quick. Sorry. Hold on. Sorry. All right. Oh man, got like no time left. Scheisse. All right, I'm gonna come in here because we're running out of time. I need some more time. So that's 0.10, right? 90% means there's 10% outside. Degrees of freedom is 6. If you look that up, you should get 1.943. Is that what you guys got? 1.943? Okay. And then if you calculate the error, I just lost my dang marker, man. Shit, hold on. I can use another marker. It's okay, John. I get plus or minus 12.05. Hopefully I didn't do that too fast. Looks about right. Yeah. Yes, okay. And then if I do that, where'd it go? 25.43 minus that, 25.43 plus that, I get 13.38 up to 37.48. All right, that is if that is somebody's estimate for the average age, would you say this is good? Average age somewhere between 13 and 37. You'd be like, you have done nothing for me. But is this evidence that wherever I am, the average age is less than 50, for example? Shit, yes, right? Is this evidence that the average age is more than 10? Yes, it's evidence. Is it evidence that the average age is more than 25? Definitely not, because this allows for it to be less than 25. I like it. I like it. Okay. Is it strong evidence? Not really, but it's evidence. My blue marker is just gone. All right. I'll get over it. Blue. Okay, guys. So we desperately have to get into, oh, sorry. The conclusion would be, true mean age. Okay. We are 90% confident. That's not going to work. You're not going to see that. What was it? True mean age. Okay. The conclusion is we are 90% confident that the interval, where did it go? 13.38 years to 37.48 years contains the true population mean age. Blah, 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 blah. Okay. Because we create a net, we create an interval, we throw it out there, and we're such and so confident that our net, our interval, caught a certain fish, the true population mean. All right. Give myself 20 minutes. Let's see what I can do. Any questions on that interesting bit of knowledge? No. Okay. I'm going to take this away. I'm going to start down here. And then I'm going to come up here. All right. Now, let's get into, that's the end of chapter 8. Right? We ended up in the middle section, but oh well. Now let's get into chapter 9. We're going to take a little baby step into chapter 9. Don't freak out. This, I've already kind of set the stage for this. This is where we actually can test claims. So I love this example because this is something we're all very familiar with, but we're going to simplify it a bit. Let's say that down in my basement, not only do I brew my own microbrew, but I have also set up a place where I can create drugs, and I mean legal drugs. So like pain relievers. In fact, I've created a pain reliever specifically for statistics students, right? To relieve the pain of a headache from listening to me or doing the homework, right? So the top pain reliever, I'm not going to become a commercial for somebody, currently has a mean time of 18 minutes before your headache goes away. You take the pill, on average, 18 minutes later, your pain's gone. Everybody with me so far? You're all copying like crazy. All right. So does this sound reasonable? Well, let me take my basement and doing this next to my microwave. So some scientist creates a drug, a new pain reliever, and the current pain reliever takes your headache away in an average of 18 minutes. The scientists, why would they create this pain reliever? They're hoping that the new one takes less time, right? So the claim that they would make, bring it back to me. My drug takes less time on average than the top pain reliever. I like it. That's my claim in English. My drug takes less time on average than the current drug. I want a new drug. Okay, so can somebody tell me, what does that look like in Mathish? This is English. What does that look like in Mathish? Or Elvish? Speak friend and enter. We need Dwarvish then. I don't know. So I claim that my drug takes less time than this does. So my claim is that the average for my drug is less than the 18 minutes it takes for the other drug. So let me put a little subscript up here, old, right? Just to differentiate between the two. Is that all right? That's basically what I'm saying. I'm saying that the average for my drug is less than the average for the old drug. This should sound like a normal claim that you guys hear about or somebody could make, right? Especially about drugs. You want it to be better than the old one. That's why you're making a new one. Now, so that's what I'm claiming, right? I made this drug. What is the opposing claim? I always think about this like two old men in a coffee shop arguing about politics, right? You're wrong. You're wrong. So what's the opposite of this? What's the opposing thing I'm fighting against? If I believe this is true, what's the opposing claim? Well, Alex, that's actually my claim. My claim is it's quicker. It takes less than 18 minutes, right? So if I'm talking to my friend, or even let's say you guys, let's pretend like you're my friends. Are you my friends? And I say, hey friends, I just made in my basement a drug and it's going to cure headaches in less than 18 minutes. What are you going to say to me? You're going to say, no, I think it's going to take long. Yes, not longer than 18. This is close. There's something you're missing. If my claim is it takes less than 18, what's the opposite of that? At least 18. Not more, at least 18, right? Yes, at least. If they're opposites, don't they have to include everything? If that was less than and that was greater than, neither one includes 18. Then they're not opposites. Okay, maybe. Can you guys see everything? So yeah, this is kind of like what I'm sort of inherently fighting against. I'm going to set up a test to see if my claim looks to be true. I'm going to see if I have enough evidence that this claim is true, and I'm sort of fighting against this. Do you guys see that? Okay, so here's the official words for these, the official words and symbols. Man, where are you, Blue? You're right in the middle of everything. Screw it. There's one called the null. Oh, crap. Can you guys see that? Is that all right? My blue is better. Null hypothesis. The symbol for the null hypothesis is H naught, H0. Heretofore affectionately known as the hoe. If you have a problem with that, it's too damn bad. And then then you have an alternate hypothesis. And I missed actually, I can't remember. To be honest, I keep forgetting to look in this book. It's right there, Jeff. I don't care. I'm too lazy. I can't remember if they call it the high or the ha. In an old book, it was the HA, which I kind of liked because it was the hoes and the ha's. But this is still good too, the hoes and the highs. All right. Those are just the names we give to the two viewpoints, right? There's always going to be two opposing viewpoints to anything. Are you guys with me? I think this. Well, I think the opposite. All right. Okay, maybe. Now, let me set this up. And again, guys, we're going to basically go over everything I'm talking about right now again in a more concise manner. I just got a lot to throw at you, so it's kind of percolating in your brain. So then watch this. Let's say, assume this is right. And we've done this in real life. Assuming you're right, look at that, you're wrong. So it's kind of like proof by contradiction. I cannot understand what it says on the bottom. Oh, okay. The null hypothesis is HO, and the alternate hypothesis is H1. Alternate, yes. Man, what a great time to get a cold. We're in the middle of COVID, so if I go to the store, everybody's like, get away from me. So let's assume what we always do in a hypothesis test is we assume this is true. Stay with me. This is so cool. And that's a geeky thing to say. I don't care. We assume the real mean is 18. So where do I want my sample to show up to show evidence that it's less than 18? If the real mean is 18 and I take a sample, a random sample, yes, you're right. I'm with you, Alex. If I take a random sample, it should show up close to the real mean, right? So if the real mean is 18, any random sample I pick should show up in here, more likely than not. Are you guys with me? Oh, somebody's trying to come back in. Oh, did they make it back in? Oh. Let me open the door. Sorry, guys. Hold on. Bam. Okay. Does that make sense? This is basically everything we've been building up to. If the real mean is 18, any sample I take should be close to 18, right? Is it impossible for a sample to be really far away? No. Is it likely? No. So if I got a sample and it showed up here, so assuming that's right, my sample should show up in here. If my sample shows over there, that is evidence that that's wrong. Because if that's right, it should be here. I got there, so maybe in reality, the picture looks like that. Maybe in reality, my mean is less. So the whole idea is, I've got a number I'm kind of fighting against. I've got to find a sample that not only is less than 18, but less than 18 enough. So let me ask you this. If somebody said, if I said my drug takes less than 18 minutes, and I gave it to a sample of people, and it took 17.99 minutes, does that seem like good evidence that it's less than 18? I mean, when I take a sample, will it be exactly the average? No. Yeah, I like that not really-ish. It's like 2 layers of uncertainty. I like it. So There will always be variability in any sample I take. So to be evidence that it's different from some other value, it's not only got to be less than, it's got to be less than by enough. In fact, this is like usual, and this would be unusual. So if I get a sample that is unusual to get, assuming that's the mean, then what's more likely is that's not the real mean, that there's evidence for my claim that it's actually less than that. Whew. Now, I know on one level, you're all very concerned right now about what the hell are these problems going to look like, right? Let go of that for now. This is Jeff talking about concepts step of this, right? Which is always bigger than what you have to immediately worry about on a problem. What determines, oh, good. Lewis, it's like I planted you out there. So in the past, unusual was always 2 steps away, correct? Now, for example, if I wanted to prove to the fire department that they opened a new fire station and now it takes less time for the fire trucks to get to my neighborhood because I want my fire insurance to go down. Yes? Who's going to set what's acceptable evidence for that? The fire insurance company. So they're going to define, they're going to make this bigger to make it harder for me to prove that it takes less time. So this is what I said earlier when we talked about unusual being 2. It's not always going to be 2 now. It's going to be dependent on a couple of things. In that case, it was insurance company greed. Another case could be, I want to make it smaller if me being wrong is bad. Like, I think my example I gave was if you're in a nuclear power plant and you're in charge, you got all the buttons, and you see a little dial starting to move towards the yellow, are you going to wait until it gets into the red to get off your ass and see what's going on? No, you're going to define unusual to be moving towards the yellow a little bit. That's unusual. You know, you don't want Godzilla and all this kind of shit, right? So Lewis, the problem itself will tell us alpha. This is where the T-score chart comes in. If I have, in this case, do you think this would be a 1-tail or a 2-tail problem? What does your gut tell you? You guys already said it earlier. What's the only side of the picture that's, no, it's not 2-tail. The only side of this picture that would show evidence for that is that side, right? This is a 1-tail test. So they're going to tell me what alpha is. I know it's a 1-tail test. I can use the T-score chart to find stuff. So that's why the T-score chart is set up as 1- and 2-tail tests. Okay, maybe. Whew. I like this a lot better, standing up. It's much easier. I think that's enough. I do want to say one more thing about the T-score chart that I don't think I've said yet. Have you guys ever noticed on this chart, do the numbers at the bottom look familiar at all? Hell, maybe not that one at the end, but 1645, we've seen that. 196, we've seen that. We've even seen 233, and we've seen 2575, right? Those are Z-scores. So remind me real quick. I know I'm throwing a lot at you. I'll let you go after this idea. What a T-score is supposed to do, cover my ass for when I'm not sure about the standard deviation, right? When do I get more and more certain about the standard deviation I get? When my sample gets bigger. So what happens when the sample is, you gotta love this shit. When the sample is large, I can use Z-scores. I don't need T-scores help anymore, because then I am really certain about my S, estimating my sigma. That's why the T-scores get smaller and smaller and smaller as my sample gets bigger and bigger and bigger, because I need them less and less and less. To cover my ass, right? Okay. It's got to be a weird moment. What happened today in class? My teacher said my ass several times. All right. Okay, I think, so we'll obviously get more into that, but I just wanted to start to throw the foundations of what the idea is behind chapter 9, and that drives everything we do. There will be 5 steps to these problems. There will be a conclusion step. You will love it so much. When I learned this, there were 8 steps. So be glad I got it down to 5 steps for you. That's it. Any questions on any of that craziness? Anybody need to hang out for a bit? Okay. Well, if you're good, let's see. With what we went over now, do we have enough info to do homework? Start looking at it. You can start looking at chapter 9 homework. I will tell you, we've obviously not gotten to any details at all. Oh, before I forget, I've already lost some people. Real quick. I think I put up, let me see if I did. On Canvas, if I haven't done this yet for you guys, I'll have to put it up here. There should be a, all right, yeah, oh, no. So there's a handout I need to put up on Canvas for you guys. It's a hypothesis test with all 5 steps with the explanation of each step. So there's a lot on there we haven't talked about yet. So do we have enough to start doing homework? You have enough to start looking at the homework. Maybe not quite enough to start doing the homework yet. So we just did a baby step into chapter 9. So I'll have to post that handout for you on Canvas. We'll go over the handout next time, but you can look at it ahead of time if you want to. Anything else? Okay. All right, guys. So if you do need to hang out, just let me know. Otherwise, I'm going to close this room of requirement down. My Harry Potter nerds? Anybody? No? That's what I think about this place. It's like room of requirement. Guy Fieri is still out there looking constipated. All right, so I'm not seeing anybody. Oh, I see Alex. I'm sorry, buddy. If I leave right now, everybody leaves, right? So I'm going to close the room. The room is collapsing on itself. Bye, everybody.